Example 202 says to find the equation of the cubic function that passes through these 4 points here, and use octave to do the row reduction. Before we do that, let's look at it on Desmos for a second. I've got those points plotted out, and this is the general form for a cubic function, y equals ax cubed plus bx squared plus cx plus d. So in theory, we should be able to move these dials around for a, b, c, and d, and eventually get it so that it touches all 4 of those points. Just playing with the dials and trying to get it to touch is going to be difficult, but we can solve a system of equations that will give us exactly the values of a, b, c, and d that we need to do this. So let's go back and look at it. The system that we're going to have for each one of these points will have ax cubed plus bx squared plus cx plus d equals y. So for this, let's see, for 2, this is going to be 8a, 2 cubed, plus 4b plus 2c plus d equals negative 4.1. For 3, we're going to get the powers of 3 going across here. So 3 cubed is 27. 3 squared is 9. Plus 3c plus d equals negative 0.4. For 4, let's see, 4 cubed is 64. Wait, is that right? Yeah, 4 times 4 is 16, times 4 is 64. So you get 64a plus 4 squared is 16, plus 4c plus d equals 10.5. Then for negative 3, all right, negative 3 cubed is going to be negative 27. Negative 3 squared is plus 9, minus 3c plus d equals 1.4. So let's take this and write it as a matrix. Writing this as a matrix is going to give us 8, 4, 2, 1, negative 4.1, 27, 9, 3, 1, negative 0.4, 64, 16, 4, 1, 10.5, negative 27, 9, negative 3, 1, 1.4. And we just have to row reduce this thing. Now, if we did this one by hand, we'd have a little bit of an advantage here because we could use this 27 to zero that one out, but we get some, it wouldn't be fun. So let's just put this in using octave. So again, I'm going to put my matrix in. I'm just going to call it M for matrix. So M is, see that top row, 8, 4, 2, 1, negative 4.1, 27, 9, 3, 1, negative 0.4, 64, 16, 4, 1, 10.5, negative 27, 9, negative 3, 1, 1.4. All right, and let's see, let me stretch this out. When matrices get too long, octave will write them, it'll break them up into a couple of lines, which is not fun to try to read. So let's do that again. I'm just going to press the up arrow to give me my same thing I just typed in. So let's see, 8, 4, 2, 1. All right, that looks good. So now I'll row reduce it, and it gives me this. Now I'm not going to copy this whole matrix off. What I'm going to do, I'll get this right in a second. I'm just going to go ahead and pull the answer off of the matrix, because that top line of the matrix tells me that A is 0.4, B is 0, But one thing you might notice, it says this sign right here says b equals. It's got a negative 0 there. The reason for the negative is because well, it has to do with the way it does it numerically. You can pretty much ignore it. 0, negative 0, same thing. Then we get c equals negative 3.9, and d equals 1/2. All right, so let's disappear octave here. And so my equation then is going to be y equals 0.4x cubed plus 0x squared minus 3.9x plus 0.5. Let's check and see if that fits all of those points. Let's see. So let's plug that in and see if it hits those 4 points. Rather than dial it in with these sliders, I'm just going to delete all of this. I didn't mean to delete my point. I'm going to delete these things. And now I'm just going to put the equation in. So let's make that a little bigger. All right, so the equation was y equals 0.4x cubed minus 3.9x plus 0.5. And sure enough, that goes through all of those points that we had over there. All of the dots are hit by this parabola, or not parabola, cubic function. So this is, it's a little bit tedious to do, but it's actually a pretty simple process. It's just a matter of taking those points. Each one of those points you plug in, and you reduce it, and you get this. So what you might want to do is do example 2.3 on your own, because it's essentially the same thing. And in the next video, I'm going to do it.